What's up everyone, welcome back. Patrick here. Moving on to the next example, we have to rationalize the numerator of this expression here. So we got the square root of 3 plus 4 root 2 over 2 root 30. Right, so we're going to rationalize this numerator here, meaning that there can't be any square roots left in the numerator in our final answer. Now notice that this is a two-term radical, right? So what we're going to have to do is basically multiply this numerator by the conjugate. So it would be root 3 minus 4 root 2, like this. However, can't just multiply the numerator by this random expression, have to also multiply the denominator by the same thing, like that, right? So it's like we're multiplying, this is just 1, this bracket. So it's like we're taking the original expression, multiplying it by 1, so it's the same expression, we're just going to be changing up the format for it. Now this here is going to be a difference of squares, so all you have to do is multiply the ends, right? So root 3 times root 3, that gives us 3. And then this positive and negative is always going to make a negative here. 4 times 4 is 16. And then root 2 times root 2 would give us 2, like that. And then over here, let's just keep these separate. So I'm going to have 2 root 30. And then over here, I'm going to have root 3 minus 4 root 2. Like that. And so notice that the numerator here is going to be what? 3 minus 32, which is negative 29. And then I'm actually going to distribute this 2 root 30 into the bracket, multiply it by both of these expressions. So this root 3, there's like a 1 here. So 2 times 1 would be 2. And then root 30 times root 3 would give us root 90, like this. And then 2 root 30 times negative 4 root 2. 2 times negative 4 is negative 8. Root 30 times root 2 would give us root 60, like that. Okay, and then these roots, root 90, root 60, these actually simplify. So notice actually at this point I want to mention that there are no more roots left in the numerator. So technically at this point we rationalized it. However, this is maybe like a multiple choice. A lot of times they'll show the simplified solution, right? And so you have to also be able to simplify any radicals you run into that can be simplified, and this is one of those scenarios, so let's go through that. So root 90, can we take 90 and divide it by a rootable number? Yes, 9, right? So we could break this down into root 9 times root 10, which would be 3 root 10. So root 90, 3 root 10, those are the same, and then root 10 we can't simplify any further. What about the root 60? Notice that we could divide 60 by the rootable number 4, right? So root 4, root 15, and then root 4 is 2. So we'll have 2 root 15. Root 60 simplifies to 2 root 15. So inputting these for the root 90, we're going to put 3 root 10. And then for the root 60, keeping the negative 8 in front, we're going to input the 2 root 15 like that. So we would end up with negative 29 over 6 root 10 minus 16 root 15, like that. So that would be your final answer right there. And this could actually also be in a different format because you can factor out a negative in the bottom. So if we factor out a negative in the bottom, the signs would change. So this negative 16 root 15, that would change to positive 16 root 15. And then this positive 6 root 10 would change into a negative 6 root 10, like that. And then these two negatives cancel out. And so you could also have positive root 29, and then basically these get flipped around, right? So you'd have 16 root 15 minus 6 root 10, right? So you have to be able to go from one format to the other because maybe the multiple choice is going to have this format instead of this one, right? So just because you get this doesn't mean it's necessarily wrong. You just have to simplify it a little further. So you got to be a little bit flexible with your simplifications. But basically these two in green and then this in green, these are all the same, right? If you plug all of these in your calculator, you're going to get the same decimal, and that's a way to check your answer. As I mentioned before, you could take the original expression, get the decimal of that, and then make sure that your final answer gives you that same decimal, right? So any of these three in green, work. This one, they're probably going to expect you to simplify those roots, so these two are usually going to be one of the final answers. And that is the end of the video. Hopefully you enjoyed that. If you want to find more videos like this, you can go to my website, allthingsmathematics.com. Over there, all my courses are organized for both high school and university. All the videos are organized by chapter. Also, if you have any questions, you can hit me up. My contact details are also on the website. Enjoy your day, and I'll catch you in the next one. Peace out.